Hello, welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Syrus Akbary, who is the founder and CEO of Wasmer. Welcome, Syrus. How are you?
I'm doing great here in San Francisco. Not a very sunny day today. A little bit rainy, but good. Thank you.
Yeah, I heard it's always quite rainy in San Francisco. Is that true?
Yeah, when I came here, I was hoping to get all the sun and people kind of like doing rollerblading in the streets, and it's not really the case. But yeah, it's kind of like sunny, let's say 40% of it. So not that bad.
Okay. Yeah, I've been to California just once in my life, and I went to Cupertino and some of these other places. It wasn't really rainy, but it definitely was colder than I was expecting. I don't know. I always hear that it's sunny and warm and nice, but I didn't feel very warm for somebody who's from the Midwest. So that's why I was a little bit surprised.
Yeah, for me it was the same coming from Spain. I was expecting the all sun, and yeah, I mean, it is what it is. It have other things.
Yeah, but nonetheless, the weather is consistent and it's still nice. And what I hear, it's kind of nice year round. But in any case, I mean, you're working on Wasmer, right? So do you mind to kind of give us the elevator pitch about what is Wasmer?
Of course. If you want, I can give you like a little bit of the story of like why I came. I mean, I will start with TLDR. So at Wasmer, we are creating universal WebAssembly runtime that allows running WebAssembly programs basically anywhere. For people that don't know what WebAssembly is, basically like in a nutshell, it's bytecode format that was created by the browsers to be able to run programs way more performantly in the browser. So this technology was initially created for the browser. That's actually why it's called WebAssembly. But one of the things that we realize is that this technology is so great that could be used outside of the browser. So similarly to what Node.js did moving JavaScript outside of the browser, we realized the same thing with WebAssembly. It will be great to use WebAssembly outside of the browser for three main reasons. One is because like it's super, super fast. So you can get into almost like very close to native speeds when running applications. Second is that it's fully sandbox. So basically like any program running on the WebAssembly sandbox cannot escape it. And this obviously is very important when you visit that website. So like it doesn't hack into your internals of your computer. And the last one is that it's completely universal. So basically like WebAssembly programs can work in any operating system, in any chipset, and so on. So those are the three main things that make like WebAssembly great. And what we tried is to move all these capabilities back to the server because they have like very interesting implications.
For building the runtime, right? There's no standard runtime at the moment?
Depending on like how you define a standard runtime. So the most used runtime in the world for running WebAssembly is V8, which is the JavaScript engine that runs behind like Google Chrome, the browser from Microsoft Edge, and yeah, a few other browsers based on Chromium. So that's the most popular WebAssembly runtime. Then after that, you have the one based in JavaScript Core, which is a browser or the engine behind Safari. And that's kind of like more or less on the client side or the browser side of things. On the server side of things, there are like multiple runtimes. So Wasmer is the most popular, but there are like many others that are like great. So you have like Was0, for example, for Go. You have WASM Edge, which is basically like it's made in C. In Rust, you have Wasmer and WASM Time. You have WASM3 in C as well, but it's an interpreter. So there are like multiple runtimes out there.
I was just kind of curious if there's like a reference implementation that everybody's kind of following, and then like the community's kind of working on that one, and then you have other implementations that kind of have more specialty.
So in the case of a runtime, there is not really like a reference in implementation. I mean, there is like one that is created by the spec test when the people from the WebAssembly ecosystem or a specification kind of like are working on new specifications together, new proposals, and so on. There is like a reference implementation there. But on the other side, no. Like, let's say like more or less like there is a specification that like all the runtimes must adhere on. That's kind of like, yeah, that's what you got. So like there are like a standard test that all the runtimes must pass and so on. So that's more or less like how you assure uniformity on a run. But on the implementation side, there is not like a one standard implementation that is more or less like used across like everywhere.
Okay. So does this cause problems when you want to run your WASM code, and that's why you see this as an opportunity to maybe make this more clear, or kind of what's your thoughts on this?
So basically, like I can tell you like the story on how I got into Wasmer. So I always been like a Python guy before kind of like coming into the Rust world. I happened to create like one ecosystem that became like very big for using GraphQL in Python. It was called Graphene. You might have heard of it. It became like very popular. But basically, like I tried to make the framework that I was creating, make it work in more programming language, not just in Python, but in Go and so on. And I realized like I could not do it. Like the only way I could do it is basically like by porting my framework to other languages, basically transpiling from Python into Go or Python into Rust, Python into JavaScript, and so on. So what I realized is if I target only one bytecode format, which in this case is WebAssembly, then I can target all the programming languages uniformly. So that's kind of like how I came into Wasmer, and I realized like this was such a big deal. And there was like nothing when I started the company 4 years ago.
Oh, 4 years. I mean, I didn't even know that WASM is that old. Like, do you know when WASM kind of got started?
The specifics, I think, was like 2017 when it got like formalized, or 2016, more or less. So before WebAssembly, there was another two technologies that were created by like two different companies. On one side was ASM.js, which was created by Alon Sakai. He was working at Mozilla. And basically, like, he did a transpiler from LLVM IR, which is actually like the same IR that like Rust is targeting under the hood when you compile your Rust programs. So he this transformer from LLVM IR to JavaScript code. But the issue is that like JavaScript code was not fast enough, so he added typings, fake typings, into JavaScript via like certain kind of annotations in the code itself. The other side, you had Google Chrome that was building native client, Knuckle. And basically like they were actually like creating like more or less universal programs, but they were based purely on LLVM IR. And at the end, like these two different companies realized that basically like working on the same goals, and they wanted to create like something open and create like a specification that all browsers can build upon. So that's kind of like how WebAssembly got started.
Okay. And I remember the demo from a long time ago. I think they were trying to show like how you can make a game using ASM.js.
Yeah, it was amazing. I was like super amazed by like, not just the game, it was like, I believe like my first point of contact was like Unreal Engine or something like that in the browser, which I was like amazed that you could run in the browser. And then after that, I remember I started sneaking on how to run FFmpeg in the browser. And on one front, you have like Pinnacle from Google Chrome, but it was like not ideal because only work in Google Chrome, and that was not the standard, and so on. But yeah, like beginnings were like I was truly surprised for like what you can do in the browser with basically like reusing your same programs, not needing to rewrite everything. I think that was amazing.
Well, I mean, so the interesting part for me is it seems like nowadays people are not really focusing on running WASM on the browser. They've been looking at Kubernetes, they've been looking at native implementation, which is what you're looking at too, right?
Exactly. So right now, like a lot of the companies that are trying to target the servers are basically like mainly focused on two main technologies. On one side, you have Docker, and on the other side, you have Kubernetes. So more or less like to put in a way, a Docker is a container system that allows you to run like universally your programs, like on both your laptop, the server from Google or the server from Amazon, and so on. This basically like gives you reproducibility. So if a program works locally for you, it's very likely that it's going to work for the server.
Okay. That is definitely one of the cool things, right? And having like this kind of platform agnostic, but don't you feel like we should maybe make two separate implementations of this WASM, or like maybe change the name? Because it seems like we're drifting so far away from web. To be honest, now that I think about it, I don't know too many people actually using WASM in the browser anymore. At least I don't hear too much about it.
Wait, I actually like, you might not hear a lot about it, but like it's widely used. So one example of WebAssembly in the browser is Figma is like, like they are doing like really great. Then you have like Google Earth, you have AutoCAD running on the browser, Photoshop or Adobe was also like looking for like running WebAssembly in the browser. So there are like tons of companies that are using WebAssembly in the browser, although it's no longer the cool kit. I mean, it's still the cool kit because you can do like amazing things, but it's true that like WebAssembly on server gets a lot of attention. And it gets a lot of attention for like two main reasons. On one side, let's say that the way that we run compute on the server, like the way that we run software containerized and so on, is through Docker containers on one front. And then the way that we orchestrate those programs is usually through Kubernetes. So the issue that right now, like some of the companies are having, is when new chipsets are coming for example, for their servers, let's say ARM servers, or new chipsets are coming for their own laptops, let's say ARM M1 MacBook Pros, basically it gets very challenging to run software from Docker. And the main reason for that is because you can only run it emulated in that chipset. So basically, like if you have a Docker container that was created for Intel, and now you try to run it on your ARM, it will be emulated. And that means like 3x, like more slowdown in speed and so on. And not just that. If you are running locally, like your Docker container in a Linux x86 laptop, Intel laptop basically, and you want to run this on a server that is ARM, that is usually like actually like 2 times or 3 times cheaper than Intel servers, like you will have a very big challenge because now like you need to pay the cost of emulation, which basically is literally not worth it. So if you want to have like one program that works universally anywhere, like in any chipset, in any operating system, and so on, WebAssembly is like perfect container or a perfect technology for that.
Yeah, but in the end, right, it does say WebAssembly. I think the name for some people can be a little bit confusing because it's not like, when I think about WebAssembly, I'm thinking about actual like assembly code, really native machine code, but actually there has to be an interpreter in there, right?
There has to be something that transforms the bytecode into something that the machine can understand. So there are 2 ways of having like WebAssembly runtimes. On one front is an interpreter. An interpreter means that like it interprets the things at runtime. And then you have other strategies for runtimes, which are like more or less compilers or just-in-time compilers. Or like there are like 2 kinds of kind of like runtimes on that front. But usually, like if you want to get into very close to native performance, what you do is you have a compiler, not an interpreter. And in the case of Wasmer, like we mainly have like 3 different compilers that are like best used in different scenarios. So for our case, for example, like we transform this WebAssembly bytecode into machine code in 3 different ways. In one front, we have like single pass, which is a compiler that is super fast to compile. Basically, you give them WebAssembly bytecode and it returns you like machine code at like super fast speeds. And this is essential for like blockchains and so on. Then you have CraneLift, which is another compiler that is also like purely made in Rust by the people from Mozilla at the beginning, because they wanted to create like an alternative to LLVM project. And then you have, in the case of Wasmer, you have the possibility of compile the WebAssembly bytecode down to machine code using LLVM itself. And that leads to like very close to native performance.
Well, the last one and the first one are both AOT, no? You said the one-time pass-through, that's the AOT also, right?
Single pass, like the main difference between AOT and JIT, basically AOT is ahead of time compilation. So basically what you do is like you need to get first like all the code you compile, and you can only run once all the code is compiled. You cannot like basically lazily run it. In the case of JITs, basically like what you have is that each function will be compiled lazily once it's used, or more or less like, yeah, as soon as it gets used. In our case, like we chose to start with ahead of time compilation because like the JIT actually introduced a lot of complication. And with ahead of time compilation, you can do some tricks, for example, saving the code in the cache of your file system and so on. So basically like the first time that you run it, it compiles it, but the next time that you run the program, actually it takes like 15 microseconds to run. So there are certain things that you can do with ahead of time compilation that is harder to do with JIT.
Well, my question is the one-time pass, that's not using AOT, right? That's using JIT?
No, this is actually like it's compiling like the single pass one, which is like the one that compiles things on the fly. It is still kind of like spits everything together. In the case of Wasmer, it's very easy to make it like JIT. But let's say like we have not chosen that approach for very good reason, because it makes a lot of things complex. Like usually you use JIT whenever like either like you want to compile things lazily or your compiler have different tiers. So for example, you have a tier where like it's super fast to compile, but not that fast to run. Then you have one tier that like it's a little bit like slower to compile, but a little bit faster to run. And then you have another tier that is very slow to compile, but super fast to run. So basically in the case of JITs, you start like with the tier 1 or the interpreter level, depending if you are in a browser. And then you kind of like detect what are the functions that get most of the calls. And then you like up the tier. Basically, like let's say you upgrade the function, depending on like what's the usage and so on. But in the case of Wasmer, we are not doing that at the moment.
Okay. Now, with all the things happening in WASM recently, right? I think, did the GC finally get standardized, or is it still going through some talks? Do you know?
So yeah, I think it's in phase 3, which is like very exciting. So more or less like for people that are not aware of like what are all the WebAssembly proposals or like what's the process there, usually like there are like 5 different phases. The phase 1, phase 2, 3, 4, and 5. Basically like phase 1 is kind of like, okay, I'm proposing this and I think this is interesting. Do people think this is worth investing time into? Then if people say yes, then it goes into phase 2. In phase 2, I believe like you start like working more on that and you try to like show an early prototype. Then you go into phase 3. Each of these steps actually have to be approved by the board. So when you go into phase 3, it's actually like, okay, like browsers are kind of like starting the implementation phase because they think this is going to be like widely used and they want to like ship the same feature at the same time. And then from phase 3, it goes to phase 4, which is basically like when the browsers actually start implementing things. And phase 5 is basically like when things are already implemented and like they just like make sure that everything is fully tested, working universally across all the browsers. And then it gets standardized. More or less in a nutshell, not sure if I confuse some of the steps there or phases, but I think more or less in a nutshell, that's what it is.
Okay. Yeah. Actually, the other issue I have is like the implementation part. Like, how standard is that? And like, does everybody do it around the same time? Because I'm still going back to like, can I use, if you know that website, just to make sure if I can use stuff.
Yes. Yeah.
Sometimes I'm a little bit shocked about what things are actually not implemented. Yeah.
Yeah. So there are certain things, for example, that took a little bit like more time. So for example, if you remember Spectre, like this kind of Spectre meltdown, which was like ways that like an attacker could gain control of your operating system by just like triggering certain time attacks. So if you remember that, basically like because of that, the browsers disable like threading in the web. And as part of that, they actually like disable like share write buffers in the browser, which basically allows you to run like WebAssembly applications. And then at some moment, like Chrome fixed it, was the first one fixing it. Then like the Firefox followed. And then iOS or Safari in iOS took a little bit of time to fix that. Sometimes they don't go like super universal, like all at the same pace because they have like different goals, let's say. And they want to make sure like their platform is secure and fast and so on. And there are other cases where actually like all the browsers act very uniformly. So on the case that you commented, for example, for GC, the people working at Mscripten, which were basically like more or less like the creator of ASM.js that I commented before, these ones created kind of like intermediate layer also in WebAssembly that allows you to run GC WebAssembly programs in non-GC runtimes, or basically in runtimes that didn't have yet garbage collection support. So that's kind of like, it's basically a polyfill, just so to speak. But yeah, in the case of GC, which is basically like doing like garbage collection in WebAssembly, I think like all of the browsers right now are like working towards that. On the server side, there are like, I believe, 2 runtimes that are trialing it. Wasmer is not one of those, but we want to get at it as soon as like the browsers basically implement it. It should take like a few months on their side. So yeah, I actually was talking with people from the Kotlin ecosystem because they are like obviously very interested into that.
I just kind of have another kind of very general question about WASM, and especially with the GC part, right? As somebody who say, well, I have to sometimes, I'm writing Python code, right? And we run on Mac, we sometimes run on Windows, and of course we usually deploy to Linux servers. To me, like, if I'm just going to use Python to run it and now GC's there, like, I don't really see that benefit, right? If you were to maybe help give some
light on why it's useful?
No, not why Python itself is useful, but like if my language already works across different platforms pretty well for what I'm using, why should I care to say maybe start switching over to using WASM? I mean, I can keep, the point of WASM is that I can use different languages now that GC is coming in and being standardized and being implemented across. I can literally bring in Python and I don't have to worry about bloating up the system with a custom GC implementation, right?
Exactly.
So like, it doesn't have to be about GC in particular, but like, what would be the benefit of running my system on WASM rather than just kind of keeping everything on the server side and running it, natively as it is right now?
So there are a few main advantages. On one side, basically like once you sandbox things with WebAssembly, it's actually like very hard to escape the sandbox. Unless like the runtime have like certain like security issues, it's gonna be very hard for you or for the program that is in WebAssembly to escape that sandbox. And the cool thing about that is that like you can get very granular into what kind of permissions you want to give to that application when you run it. So let's say you're running a Cowsay program that basically like prints certain things on the screen. And by default, you can say like, okay, I'm allowing my program to print things on the screen. But then you want to make the program more complex. And now you just not want to print things on the screen, but you want to retrieve things from a website. So one of the things that you can do with WebAssembly is that because you let the user or the implementer basically define the system call layer, you can actually become very granular or what are the things that you are allowing the people to, or the program to use. So for example, you can say, please run this program, but let it only access google.com. or run this program and don't allow any network, or use this program and don't allow access to any kind of file system, or use this program and only allow access to this folder specific. Don't go outside. So these kind of things, you can do it in WebAssembly, let's say like very, very easily. Not just in WebAssembly, also in WASI, which is like system implementation more or less for WebAssembly. So that's kind of like one of the main advantages. On the other side, when you use Docker, there are basically like virtualization techniques that you can use to shield your program. But let's say that you usually like to be able to run your code super, super secure, you have to go through more or less hardware virtualization layer like KVM or something like that. So it's usually like, let's say like not as performant or not as good as the bytecode approach with WebAssembly.
Now, the permission system is opt-in or opt-out, or can you do some kind of doing the same way? Or how do you say that? You can have both sides.
It really depends. So basically like in this case, let's say like WebAssembly is agnostic of the system layer. So of the API layer, for example, that the program uses. So for example, you can have a program that targets WebAssembly using mscripting in Rust. And you can have your same program target WebAssembly with WASI. And these two define different ways of opening files and different ways of treating with the network and so on. So basically like it depends on this latter part, which also like runtimes implement. So like as a runtime, you have to implement on one side the virtual machine and on the other side, the system call layer. And there are like multiple ways of running the system calls or multiple specifications for that. One is semi-scripting. There is another one that is unknown, which is like what happens when you use, for example, WASM bindgen in Rust. So basically like there are like multiple layers. And depending on the layer that you use, the layer will allow you this granularity or not.
Well, my question is because sometimes like when everything locally and you think you got permissions done, it should be fine. Then you go to deploy and you're like, oh crap, I have to allow this. Oh, forgot that. And then you just end up saying, okay, just allow everything because it's so annoying, right? That's the kind of the question I have. Is there like the permission system, is it a combination of you can have like an allow all or deny all and then like add in or like add approvals or add rejects or something like that?
Exactly. So there are different, let's say like each runtime is doing like this, doing this differently. So for example, you can say like, oh, I'm allowing like all the network at once, or I'm just allowing like certain website. And it's true that like, if you don't nail down the ergonomics great for the permissions, then like everyone will end just accepting everything by default, right? Like it's because like it becomes non-useful. But one of the approaches I really love is, for example, how like iOS or Android has been like dealing with permissions, which basically by default, when you install an application, the application manifest describes what are the permissions that this app needs. For example, this app is gonna want access to google.com, or this app is gonna want to have access to your webcam, or this app wants to like emit audio or anything like that. So basically like I believe like one approach like that where more or less like you can define like your permissions based on like a static manifest could be like super beneficial. But again, this is like not standard and each runtime is doing this thing differently.
Yeah, the more things that are non-standard, the more things I feel annoying as a developer. If you ever want to change something, change
300% agree with you on that front.
Well, I mean, maybe we can kind of go. So we got a pretty good information about like WebAssembly and why I should use it. But now the question is like, what is Wasmer doing different than say other implementations, and why should I be looking at Wasmer?
Okay, so the main thing that we are doing is we started by creating the runtime, but the main thing that we are doing is we are focusing on the developer experience. So just by like the name that we use, it's actually like a combination of two factors. One is WebAssembly and the other was Docker. That's actually what inspired me to use the Wasmer name. And the main reason I started Wasmer is because it became like super hard for people to use WebAssembly on the server. It was like super challenging. So I wanted to improve that. I wanted to have the perfect developer experience. So it was like trivial for developers, especially in Rust, to be able to use WebAssembly server side. So why people should use Wasmer is basically like, I mean, rather than trying to convince people, like what I'm trying to do is just making sure that we have like excellent ergonomics for using WebAssembly on the server side. So basically a very easy to use API, an API that is extensible, an API that you can customize for like your custom use case and so on. So in this case, we are trying kind of like new things and we are like basically trying to develop new standards, but people that are kind of like curious to try an API that is easy to use and will get them to kind of like more or less lose their fear on using WebAssembly on the server side, probably like Wasmer will be like the right call on what library to use on the Rust space.
Now, to install Wasmer, I mean, is it just like a simple, can I use Homebrew on my Mac or like how kinds of, how's the installation process?
Yeah, so there are like two ways of installing Wasmer. So Wasmer itself is a CLI tool, so basically a
Mhm.
command line interface that you can install in your shell. And Wasmer is also a library that you can use. So depending on your use case, you can use Wasmer in your CLI on your shell, basically, or you can use Wasmer as a library embedded on your Rust application or your Go application or your, I don't know, like name your programming language, Wasmer is probably present there. So depending on like what your use case, you can use Wasmer as a library or as the end application.
Was just checking your programming language, see if it's supported and something here. I don't know. I have to take a look at it. So that's interesting. Now, to go into a little bit more specific, one thing I did discover, and you were touching on it before we started to record, which was as a Rust podcast, we're always, promoting Rust, and you're not using
Yes.
Rust actually, which is kind of surprising because I mean, I think the support for Rust language itself in WASM is quite high, but you're not
Yeah.
using Rust itself to run WASM, right? You're using Zig.
No, we are actually using Rust. Like Wasmer itself is made in Rust, but for certain things that we are choosing other tools. So for example, you remember when I talk about like ahead of time compilation,
Mhm.
where like you can take your WebAssembly programs and compile them ahead of time. So the next time that you run them, they run super fast. So at Wasmer, like a few months ago, we created one thing called like native executables. So basically what this is given a WebAssembly program that you give to Wasmer, Wasmer can generate a .exe file that will work on Windows or will work on Mac or will work on Linux. And for that specific thing, cross compilation aspect, we are actually using Zig because it's like super interesting. But Wasmer itself is actually like made in Rust.
Oh, okay. I was under the impression that the whole thing would be made in Zig.
No. I mean, I love Zig. I think it's a very amazing language. But for our case, like before starting Wasmer, I actually like spent a lot of time trying to see like what was the best ecosystem to create a runtime on. And I actually spent like weeks trying to analyze the code base of V8, which by the way, it's great, but it's a mess. It's like super hard to read. Then you have like JavaScript core and so on. And I realized like Rust could lower the barrier for people to try to contribute into the WebAssembly ecosystem because C and C++ is very easy to shoot yourself on the foot in certain things, especially if you are creating virtual machines. But Rust on the other side is way more safe. So for our case, like Rust was the ideal language to be using for creating a virtual machine.
Well, that's good to hear because I was a little bit upset when I first heard it, but Zig is still a good language, of course. But we know on this podcast, we all have our biases, right?
It's normal. I mean, don't get me wrong. I love like for me, like any programming language that gets there and like tries to basically make better ergonomics and so on, like is welcome. For our case, Sig is makes sense for certain use cases, but for the core of the things that we do, Rust makes much more sense for us. Perhaps for other people, it's gonna be different, but for us, Rust like makes a lot of sense. Also, like Rust is making like a comeback towards operating systems. Rust just got like integrated recently into their Linux kernel and so on. So basically, like I think Rust is a very great fit because it allows you to not shoot yourself in the foot that easily. And that when you are creating operating systems or virtual machines is essential.
Okay, that's always good to hear. Yeah, so Wasmer, right? If when I'm deploying this thing, is it compiling into like a single binary no matter which kind of format I'm using to do?
So there are like two different steps. One is, let's say, created the WebAssembly application or the Wasmer container, and the other one is running it. So for creating your application or for compiling your application towards WebAssembly, there are like certain tools or languages that you can use. So for example, if you are using Rust, it's mostly trivial to compile towards WebAssembly. So there are different tools that you can use. By default, you can use WASI, for example, if you want to compile like your normal like CLI application towards WebAssembly and make it universal. But then on Rust, you also have WASM bindgen, which basically allows you to run Rust code in the browser very easily through WebAssembly. And I actually love WASM bindgen. I think it's genius. It's super awesome. It allows you like to use web APIs super easily in your Rust programs as well. So it's very magic. So that's one front, basically on compiling your program to WebAssembly. And depending on like what programming language you use, you can use different tools for it. So again, if you are in Rust, you can use like the WASI toolchain and install it and compile it to WASI. You can actually also use MS Scripting. You can use WASM bindgen. So there are like multiple ways that you can compile towards WebAssembly if you are in Rust. If you are in C, you have Emscripten mainly. That's more or less like the most famous way of compiling from C to WebAssembly. Then if you are in Go, the Go compiler also supports natively compiling to WebAssembly, but only on the web, funnily enough. Go doesn't support yet compiling to WebAssembly outside of the web, like Rust and C does. If you're using Python, because Python, for example, is using a C implementation under the hood, it's possible to use Python on the browser. And as a fun fact, actually, if you go to wapom.io, which is the package manager that we create for WebAssembly packages, we have actually one package that allows you to run Python online in your own browser, which is very exciting.
Yeah, there's definitely a lot of stuff happening in WASM. It seems picking up every day. I'm just kind of curious, what is the most exciting feature that's coming out or maybe even just came out in WASM that you find like really just makes you super excited?
So there are a few things that we are very, very excited. So I actually share with you the excitement on GC because I think that's going to make certain programming languages target WebAssembly like more or less like as a no-brainer, because on one front they can get like very small WebAssembly programs because they don't need to have the GC included on the WebAssembly binary, which is very nice. So that's one thing I'm excited about. I'm excited about like the type reflection API on the browser because it makes certain things easier. I'm excited about one new standard that we are actually creating. So I talk about WASI, which is a system interface layer that allows you to run your WebAssembly programs more or less server side. But the issue on WASI is that for a long time, it didn't support threads. So if your Rust program uses threads, you cannot use it. And then you cannot use actually like sockets yet or fully use sockets yet, which is, and basically we want to like close the gap. And at Wasmer, actually, we are creating a new standard called WASIX that more or less like you can imagine kind of like a POSIX extension that allows you to run or compile any POSIX kind of program into WebAssembly. So basically like you don't need to modify in any way or form your program to be able to target WebAssembly. And this gets me like super, super excited. I think this is going to open a lot of doors for everyone looking into this space.
But you said Wasmer is actually proposing to add some features to WASM, right?
Yes. Right now, like the way that we do these things is we start with prototype, and once we get the prototype working, then like we will probably try to submit it as a specification. But right now, like let's say we are working on the hood to make sure that everything is running well. Hopefully, like we are gonna launch in a few weeks or in a month, or like these things, timelines always get longer than you wish as CEO of a company, but that's okay.
Now, I'm kind of curious, as somebody who's submitting these kinds of things, I mean, there's a couple of things that are under my mind. One is that you're always afraid you're going to get flamed, right? Because it's like, oh, you don't know about this or you don't have enough information to understand all the stuff that's going on. Like, there's this kind of like, oh, I'm an expert and, you're a beginner, you don't know what's, because I'm deep into this, right? That's one thought process I have. Another one, too, is that like, I believe the big people on these committees are like browsers, right? So they also have their own ideas about what should be done. And is there like some kind of like infighting, like, oh, we don't want to support that, or oh, we're already working on something that's going to cover that? Or I'm kind of curious about the process, about how you would submit a feature and what kind of feelings do you get when you're doing it?
So first of all, like I think you're completely right. Like in certain ecosystems, there are like people that don't want to move certain things forward because they don't like it. So for example, in the Rust ecosystem, there are like people that like are working on the WebAssembly side of things, and they don't really like POSIX because POSIX have certain flaws that are true, and basically it makes it harder to work with it. So they don't like POSIX and they want to break with it. And that's kind of like purely philosophical to say in one way. They don't like it. They are like probably right on the things that they are on the reasons why they don't like POSIX. But at the same time, POSIX is like used basically always for any program. So if you want to break with it, it's going to come with consequences. And the way I like to look at about these kind of problems is always start from like what problem you want to serve and what problem you want to solve. And basically like don't look at this problem from like a perspective of a user, kind of like, okay, how I can help this user to like, for example, target the server more easily. Like what is stopping this user from using WebAssembly? In this case, for example, threads was one of the things that was stopping the user for using WebAssembly in Rust and like on high performance applications. So we always want to start from that end, kind of like what kind of value can we deliver? And then like we backtrack into the technology. Like I'm on that front, like a little bit more practical, because otherwise like you end into a world where like rather than like trying to bend the technology towards your needs, you end bending your needs toward the technology. And I think it's not the right call.
Now, I'm getting, another thought came to my mind, right? Because we're adding in GC, where you're talking about adding in threading. At what point do we go from WebAssembly, where, obviously you're committing kind of like from scratch the whole entire program, to where, okay, we have GC, we have threading. You don't need to add these to your program, right? Like, I understand that it slims down your WASM, output, but at the same time, it's like, well, you're kind of losing the benefits of WASM, where like, if you're writing with C, you're going to get much more better performance because you don't have all that runtime stuff added into it. Do you know what I'm saying?
Yeah, I mean, from the way I see things is basically like when you try to run like them, let's say like you have a program that is using threads. Right now, the issue is actually your program that is using threads will not compile to WebAssembly, like will not compile this. So like that's your first roadblock. So on that front, like it's not a matter of like, like what's possible or like what's not possible. Like if you're in Rust and you're using like multi-threaded program, unless you are using it with Rayon, which is the only way that you can use Rust with multi-threading in WebAssembly in Rust, unless you are using it with Rayon, you are not going to be able to use multi-threading. And that for us is an issue. Right, like, and we want to solve that. We want to allow like multi-threaded programs running. So it's more like comes from a perspective of like, okay, what can we help solve that right now like will get more people into the ecosystem? No matter on like, we believe threads are awesome, right? So like we want to enable them. So basically we want to keep kind of like iterating to make sure like WebAssembly becomes way more accessible over time.
Well, the reason I'm asking, because I start to feel like WebAssembly is kind of coming to like a .NET, where it's like you can just run any language and you're going to get approximately the same output depending on, I guess, how it compiles, which is kind of the way I'm seeing it. Like, is that the direction that we're going into?
Yeah. So on one front, you have like .NET, which is like, it could be run also like ahead of time mode or like in kind of like with a VM. This story is very similar to the Java story, where you have like the JVM, right? Like you have one universal bytecode that runs anywhere. The main thing is usually like on the programs that were on .NET or on the JVM and so on, the issue is that like if you want to run Python programs on the JVM, for example, you cannot run it with the normal C Python. So there might be actually differences when you run your Python code in Java, let's say using Jython. Why? Because the interpreter or the program, like Python program, is actually like not the same. The cool thing about WebAssembly is actually unifies all these different languages. So the runtime is actually the same. So if you're in Python and you want to compile your Python program to WebAssembly, you can assure that like the native Python and your WebAssembly one are going to be the same. Whereas like in the case of .NET, of the JVM, usually they require reimplementation. Where that for me, that was kind of like the big mistake, or like what didn't help like Java to basically like conquer the world. It didn't offer like a transitional way of using it. So if you were using C, you could not use your C programs on the JVM. On the other side, on WebAssembly, if you're using C, you can use your same C programs. They're going to work exactly the same, but now they're going to be on web. So they are the same program. You don't need to rewrite your stuff, which I think is a very useful thing to have.
Yeah, so you mean that lie that we were told about Java, write once, run anywhere, is not going to be the same for WASM, right?
I think, yeah, in the case of WebAssembly, I think we are going to get truly into fulfilling that space and fulfilling that need. And the main reason for this is because almost any language is adopted. Like Python has already adopted like WebAssembly with both TypeScript and WASI. Rust have done it fully. Rust was one of the first ones adopting WebAssembly, and actually I believe that's one of the reasons that actually like got Rust as well like super widely adopted on a lot of different scenarios. But yeah, I think it's the great thing is like the languages, they don't need to be rebuilt on WebAssembly. They just like can compile into it. And the main reason this is possible is because most of the languages are compiled to LLVM under the hood. And because of that, you can compile very easily from LLVM to WebAssembly. The same thing that we commented for ASM.js, that was basically compiling LLVM to JavaScript. Now you can do the same, but with WebAssembly. And that basically like is one of the best things of WebAssembly. Almost any software will be able to target it like more or less in a trivial manner.
Yeah, okay. You're definitely changing my mind about this, because I'm just not too sure about running WASM yet. It hasn't come up yet, but that's something I know is going to be something I'll have to play around with soon, because it seems like it's gaining more and more traction.
There are like a lot of things that are super interesting that are happening on the Rust space. So for example, we know like there are like multiple terminals that are coming from the Rust ecosystem. One of those was Warp, which right now I believe is closed source, but Warp is actually like trying to use plugins with WebAssembly based on WebAssembly. Then you have as well like some IDEs in Rust that are using WebAssembly to allow users to create plugins for their IDEs. So very similar to Visual Studio Code, but the issue on Visual Studio Code is all the plugins are made in Java. In the case of Rust, and for example, if you are using IDE, it's very easy for you to embed a WebAssembly runtime such as Wasmer, and then like use a universal library that is created by one of your users in your IDE and assure that it's going to be sandboxed, it's not going to be able to do harmful things and so on. Then you have like other projects like ambient.run that was launched a few weeks ago, which allows you to use like to create like multiplayer games using WebGPU, which is, for those that don't know, like WebGPU is more or less a way for running like very performant or very high performant resource intensive, graphics intensive resources on your system. It's actually like widely adopted or being widely adopted by the browsers and so on. So they are creating kind of like a game engine in Rust, and the people from ambient.run, and they are targeting the browser using WebAssembly. So a lot of like use cases that are coming right now that people are realizing of this.
Yeah, it's definitely looking interesting. I'll have to kind of see what's going on. I think I have some ideas about some stuff because
Yeah, what are your ideas?
I don't know, because there is something where I need to run some code and I would like to run into a sandbox, and it's not entirely sandboxed at the moment. So that may be something I'm taking a look at. Just
Yeah,
thinking about that.
that's a specific, like very useful use case for WebAssembly where you want to run like untrusted code safely and at super fast speeds. For that, WebAssembly is really ideal because it assures like all these sandboxing properties that like you would like to have when running like untrusted code. So that's definitely like one very good use case for WebAssembly.
Yeah, it's something I'll have to take a look at. I'm still considering. I have to play around and see because we have a bunch of stuff written in another language. So I'm not too sure. Yeah, have to see. But that's something I'm going to consider now.
Yeah, there is, for example, other use case that for now, like it's becoming like very important. So we have been working in WebAssembly or WebAssembly Visual Code extension that basically allows you to have like syntax highlighting on WebAssembly if you are using Visual Studio Code. Right now, like we wanted to add a new feature that actually like is using like a new standard that we are creating called WebAssembly interfaces, and we wanted to add support for the syntax on the Visual Studio Code ID, right? Like so you have all this nice kind of like highlighting and auto completion and so on. We found one issue where basically like we are Rust fans, right? So we are using Rust to create like this IntelliSense server for this new spec that we are creating, and this thing is made in Rust. But the issue is that right now, when we want to create or distribute this plugin, now we need to distribute the plugin into like all the different systems that exist out in the world, right? Like if you are using Visual Studio Code in an R machine, we need to distribute one binary for that. If you are using Visual Studio Code in a Windows Intel, we need to distribute that. If you want to use plugin in Linux with ARM or RISC-V, we need to distribute a new plugin, which is basically a pain in the ass. And one of the things that we are doing is that we want to use WebAssembly to only emit or only use one file and use this file universally across any operating system and chipset, which basically gets the promise of like literally like what WebAssembly is really good for, which is this universality and sandboxing.
Yeah, sounds exciting. I know sandboxing is definitely something that is talked about a lot, right? That's one of the key features of WASM.
Yeah, that's probably like one of the things that like gets more people into plugged into the ecosystem. But I get your point from before, like sometimes like you have to be careful on like how to define like the permissions ergonomically, so basically they don't become a pain in the ass for the users, because otherwise no matter how good your or how granular your permission system is, if everyone is saying yes, it's not worth it. Like basically like it didn't accomplish its goals.
Yeah, I just remember in my past when I was trying to play around with vBulletin or some PHP thing, I would just chmod 777 everything and something wasn't working, and that would usually fix the problem. But later on, figuring out chmod 777 was definitely probably the wrong thing to do.
Yeah, it's funny because I actually came from the PHP world like long ago. I think it was like 21 years ago. I used to love it, then I used to hate it. And then I realized like PHP is actually like very good for this thing that we are calling serverless, because it's actually like making execution per request. So actually I learned to appreciate it back again. I mean, I don't write it that much because I think I don't love it. But like I learned to appreciate the things that I did not so before. So yeah, definitely interesting that.
Yeah, I find it weird that you can write scripting languages with PHP, but I mean, I guess if you like a language, you'll find new ways to use it, right?
Yeah. The end is kind of like find the right tool for like what you want to use. And one of the best things of PHP was actually being able to run like almost any program like easily. But one of the side effects is that it was insecure as fuck. Like it was like super insecure. So basically, like I remember hijacking into like other people's servers by like I don't know, like just using exploits from WordPress and all that thing. So but the cool thing that actually like just kind of like to give you a sneak peek of things, we actually like compile PHP to WebAssembly. And the cool thing about that is that like then now you can run WordPress fully sandboxed, like without worrying about like that someone is gonna hijack into your system and make things like super, super interesting. Right? Because like now you can make something that was tend to you to be unsafe, you can make it safe by using WebAssembly.
Yeah. Well, that's basically what kind of a little bit what PHP hack is, right? Just trying to make PHP work for the next generation, or I don't know what you would even call that. Just trying to make it
Yeah,
work,
yeah.
I guess. Make it work for you in your use case.
So yeah, definitely like people can like see WebAssembly as a way to sandbox their already existing programs. And I believe like WebAssembly is like a really great contender for that. Yeah. There are like other things that we have like not chatted about that might be like super interesting. Remember, like I just mentioned, kind of like, okay, we want to compile PHP into WebAssembly and so on. So basically like one of the things that we are doing at Wasmer is we want to make like any kind of application compilable to WebAssembly. So you can bring all these nice capabilities of running like programs completely sandbox and basically like fast as native and then like super cheaply because you can target almost any chipset and you can run it embedded if you want. You can run it on your IoT devices and so on. So we are bringing kind of like all these like nice capabilities and basically imagine in the future if you want to run like super easily like WordPress in your Raspberry Pi and you don't want to like mess with any kind of like with installations and so on. You just like worry about like installing Wasmer and then like everything will run magically on your system. So that's kind of like the kind of world that we are trying to go into.
Something I'm kind of curious about now is, does it actually work with GUIs too? Because GUIs are very much per platform now.
Yes, you are completely right there. So we did a sneak peek of GUIs in Wasmer. Actually, we got like Game Boy emulator running in Wasmer. I think that was like 2019, so almost 4 years ago or 4 years ago. I forgot if we released it in March 2019 or when exactly. But we did a sneak peek of using GUIs with Wasmer, which was basically using a frame buffer tree, where basically like all the screen more or less is a buffer in memory. And then like you use that as kind of like pixels that you can draw around. And yeah, you can kind of like create these kind of integrations. But I think the most interesting ones is, for example, when WebGPU fully comes with bindings into WebAssembly, then you could run like imagine like the future of Electron, where basically like I mean right now there is one Electron in Rust called Tauri that more or less like allows you to create like Electron like apps in using a lot of like very nice things from Rust and the operating system browser. But imagine that like yeah, we believe in a place where actually you can also like run GUIs, like you can run like the future of Slack, where actually like it's not using Chromium under the hood and consuming like 2 GB of memory when using it, but it's consuming like a few megabytes and it's completely like sandbox as well and so on. So yeah, I believe like the future of GUIs as well goes in WebAssembly. And I want to do like a call out on one project that I loved is made in Rust. I'm trying to remember the name. Basically, it was an IDE that fully worked in the browser and it was super performant. It only like weighted a few kilobytes and it worked like natively on Windows, natively on Linux, Mac, and also like fully on the browser. I think the name was MakePad. If anyone wants to search like makepad.dev, I think they were using like WebAssembly as well for targeting the browser. And I think, WebAssembly will be a big contender for using GUIs universally.
Okay. Yeah. It's interesting. I'm looking forward to the future. Let's see what happens. It seems like it's just getting more and more interesting these days.
Yeah, I'm literally like truly excited about like all the things that are coming next because first of all, like right now WebAssembly is gaining a lot of attention, right? And
Mm.
people are looking into this and saying like, oh, what can I use this for? But the more useful thing is basically like WebAssembly is becoming useful for people. Like they are like, oh, we want to use this program and we don't want to rewrite our program. We just want to use the program that already existed, kind of like in this ecosystem. So for example, we have like one company that we were chatting with that wanted to do like Zoom-like application where basically like each of the nodes were like running Rust and were using UDP and so And yeah, basically like they wanted to target the edge computing and so on, and they wanted to see if it was possible with WebAssembly. And I think that's kind of like a very interesting use case for basically like trying to target the next generation of applications. So yeah, I don't know. I think I'm super, super, I mean, I have to be, right? I'm the CEO of Wasmer, so I have to be excited about the ecosystem, but I'm genuinely excited about like all the things that are happening and all the but all the powerful brains that are coming into the ecosystem.
Okay. I think we just about reached our time. And of course, I could see this topic going on for a long time, but there's lots of talk about it with this. But yeah, I mean, maybe kind of one last quick shout out. So if people are interested in kind of giving a try for Wasmer, how can they get started?
So you can go like to wasmer.io, to our website, or go to the GitHub project, which you can find the link as well, like our website. You can search for like Wasmer in Google and go for it. I'm going to do a sneak peek, basically for people that are looking into WebAssembly as well and want to work on these. We are also hiring. So blameless, shameless plug into kind of like we're hiring. If you are talented and are looking to space, we are looking for you. But having said that, I think just kind of like people like Codebase is not very complex. So it's welcoming. There are like certain issues that are good first issues if people want to contribute into the space. And basically like this is a very like living ecosystem. So sometimes like if people want to like the experience on like how it's working in open source project that is thriving and so on, I think like Wasmer is kind of like a good community project to participate on. There are like so many projects using like WebAssembly that I would encourage them to take a look at. But yeah, Google probably like it search away from like finding Wasmer and how you can contribute.
Okay. And with that, thank you again for coming on. And I'm hoping to see more and more interesting things from both WASM and Wasmer.
Awesome. It was great being here. Thank you, Alan.